Before we get to the code, I'm going to briefly explain how the results from the model prediction is commonly shown. The most common way is through a confusion matrix, which you see on the screen. Despite the confusion matrix name, it isn't actually that confusing. The first column of the matrix is all the females in the dataset, and the second column of the matrix is all the males in the dataset. In the upper left corner is the number of correctly predicted females, and in the bottom right corner is the number of correctly predicted males. In the bottom left corner is the number of falsely predicted females as males by the model, and in the upper right corner is the number of males falsely predicted as females by the model. Respectively, these are called true positive, true negative, false negative, and false positive. So you can think of FP as a type 1 error, and you can think of FN as a type 2 error. Several terms that you should know is balanced accuracy, sensitivity, and specificity. The main difference between balanced accuracy and accuracy is that balanced accuracy gives a better representation of the true accuracy of the model when both groups are not equal in the number of people that are in there. In most datasets that you'll create or that you'll find online, most of the time the groups are slightly unequal in some kind of regard, and I would always recommend to use balanced accuracy over accuracy. And sensitivity is true positive divided by true positive plus false negatives, which equals 90% in this case. And the specificity is the true positive divided by the true positive plus the false positives, which equals 60% in this case. And if you add sensitivity plus specificity together and divide it by 2, you'll get the balanced accuracy. So now we're going to use our model to predict the sex on our holdout dataset based on the features that are going to be fed into it. So I had to add in a few extra lines just to make sure that the confusion matrix was outputted correctly. We can see our model did pretty well. It got an 80% balanced accuracy, which is pretty good for just off the bat. So let's check why sensitivity is so much higher than specificity. So the confusion matrix is a 2x2 grid, and it provides what the actual category is and what the model thought the category was. So we can see that the model correctly predicts 21 out of the 22 females and accidentally classifies one of the females as a male. So this would be why we have such a high sensitivity. It's because our model is doing such a good job at classifying females as females. But we can see that only 13 males were correctly classified, and that is why our specificity is at a lower percentage. So that wraps up basic classification. There's definitely a lot of areas that can be improved upon. You can definitely increase the specificity, if I can learn how to pronounce that word. And the next video will be about stacking different models together to improve classification accuracy.